how do you estimate? You start with the size estimation. So that's important. You need to understand the size of something. Is it big? Is it small? Is it medium? So it really depends on how you would actually get to that. Now, what you define as big vis-a-vis what I think is big. So you need to have some kind of benchmark for that. And that's why, we use t-shirt sizing, because the t-shirt sizing don't really vastly differ so much in terms, at least of one geography or region. So that's why we've got Europe or UK sizing is slightly, which is all consistent, fairly consistent in terms of, for example, if you compare that to the US, they've got a completely different way of sizing. But still there is a standard, right? So there is a US standard sizing of t-shirts, which is one standard, which is compatible with all the people in the US, whereas it could be different from those in the US, from the Asia and from Europe. So you need to have that kind of a rough idea. We're talking really rough idea. Nobody's really interested in the specifics and they give me the exact number. So if that is the case, there's no point of estimation in the first place. So the input for this kind of size estimation is the requirements. Unless you know what you want to develop, what is the vision for this? You need to know the vision, the requirements, the stories, the functionality, the house. Unless you have these, how can you really kind of estimate? So that's where you need either the images of the house, or the dimensions of each room in the house, or you need to have a blueprint of the house architecture, or at least some idea, just some numbers. Give me the number of rooms at least, right, in the house, so that I can come up with the quote for the painting. How much paint do you need? How much of wallpaper do you need? How many walls do you have to have the wallpaper in? How many coats do you need to have? Do you have single coat or double coat of the paint, right? All of these will kick in. Do you want different paints for each room or the same? So all of these are required for you to be able to actually arrive at the size of the house, first thing, right? So those are all called what we call as requirements. The ability to add the items to the catalog, that's a requirement. And then the processing of the functionality to remove the item or to actually change the number of the quantity of the items. Again, that's a functionality. So when you give these things, then you know, oh, these are the areas that the user would actually kind of interact with the system, with this website, e-commerce website. And then accordingly, you can actually have you can apply the productivity. So once you have the size, then you actually kind of look at the productivity. We were talking about velocity, right? So velocity in the context of agile is roughly equivalent to productivity in the normal term. So productivity is, for example, if a painter is able to paint one wall in, let's say, 1 hour. I'm just giving an example. So that's the productivity of this painter. You know what? It's not the same for every painter. One painter who's experienced, who's got the roller, for example, he's using roller. He's using a roller painting to use this, paint for this house. He can do that in, for example, 1 hour for one wall, right? And the same wall, same size, yeah? Same size of the wall, the same paint, for example, similar paint, let's not change those variables. Then somebody else who's using a brush, he's not using a roller, he's actually using a brush. That person might actually take 2 hours for doing the same wall. So what you're trying to compare is the same set of variables. That's something which you need to consider. And so you need to have a clear picture about the methodology. What's the kind of methodology they're using, the tool they're using? Is it the brush or the roller? Are they using Visual Studio.NET or are they using Java? If they're using Java, there's completely different. If it's C# coding, they're using Visual Studio.NET, then potentially two developers could potentially have the same set of level of productivity. But you know what? There are other factors. The person might be junior. They may not have enough experience of working with Visual Studio.NET. In that case, again, the productivity might be lower than the person with 5 years of experience with more exposure to using .NET, the Visual Studio.NET tool. So you need to understand also the phase in which you're working on. So if you finished one code and you're just giving a rough code the second time around, then it doesn't take 1 hour, right? So you're talking about some of the variables, dependencies in that context. Similarly, if you already have a database and you have some table already there, the data is already in there. You don't need to even migrate that data into the new database. Given that, then the effort and the productivity to actually code something is far, far simpler than, for example, in a case where you need to completely rebuild the database. You need to have a database. You have to design a database schema. You need to come up with a model for the database. You need to actually start, putting the tables into the database, into a SQL database, for example, create an SQL database, add the tables, add rows and columns to each of the table, define the table, and then, import the data into this table. Or if you don't have that migration tool, you have to actually manually do the, migration into the porting of the data into this table. So there, the productivity would take a different meaning there. So you need to really consider each of these.